Hello everyone. In this series of videos, we're going to start with another topic, which is another application of NLP is language detection. So let's start by having a brief introduction about machine learning. So every machine learning enthusiast has a dream of building or working on a cool project, isn't it? So mere understandings of the theory aren't enough. You need to work on projects, try to deploy them, and learn from them. Moreover, working on specific domains like NLP gives you wide opportunities and problem statements to explore. Through these videos, I wish to introduce you to an amazing project, the Natural Language Detection Model using NLP. So this will take you through a real-world example of machine learning. So let's get started. Basically, what this language detection model will do is basically if a paragraph is written in some language, so the model will able to find out that which language it is. So that's what the task of a language detector. And in this series of videos, we will be creating a very simple language detection model. So before we start, let's first start with the dataset. So I've already uploaded the dataset, which is the language detection CSV. So this dataset contains text details for 17 different languages, and the languages are basically English, Portuguese, French, Greek, Dutch, Spanish, Japanese, Russian, Danish, Italian, Turkish, Swedish, Arabic, Malayalam, Hindi, Tamil, and Telugu. So using this text, we have to create a model which will able to predict the given language. So this is a solution for many artificial intelligence application and computational linguistics. These kinds of prediction systems are widely used in electronic devices such as mobiles, laptops, etc. for machine translation and also on robots. It helps in tracking and identifying multilingual documents too. So the domain of NLP is still a lively area of researchers. So let's look at our dataset. This is our dataset. You can see a text is, and another column is language. And you can see the text, nature is the broadest sense, and finally after comma you can see the target label, which is English. So this is how every language is given. If I scroll down, you can see different language too. Yeah, this is the different languages which are not uniquely encoded in this particular thing. This is for different language. You can see it is basically Portuguese. This particular language is Portuguese, and yeah. So this is this data. Now let's start the coding. So the first step that we are going to do is going to import the important libraries. So the first library that we are going to import is none other than pandas with the different aliases. Then we are going to import NumPy-NP for handling regular expressions. We need regular expressions. For visualization, we are going to have CBonds, and also along with CBond, we're going to have CBond, we're going to have matplotlib pyplot.splt. For saving our model, we need pickle library. We also need to deal with the warnings. So we don't want any warnings to come into our way. Filter will ignore the warnings. That's why you have to stop. Now when I run this piece of code, and here we go. Now next step is to load the dataset. So for loading the dataset, CSV, and we have to just take the path, column, pass the path name, and then coding we will be using as Latin one. Press enter. Dataset will be loaded. Just see the dataset. Okay, So here we're getting nan. So these columns are basically not for our use. Where the first two columns are of our use. Now we'll drop the column. So for that we just use data, two square brackets, and we'll just name the column. Just need text column, and we need the language column. And yeah, this is the data set. First 5 text are of English alphabets. That's why we are able. So as I told you earlier, this dataset contains text details for 17 different languages. So let's count the value count for each languages. So for that, we just have to do languages, okay, with capital L, dot value underscore counts. Now when I run this, you can see for English it has 1385 entries, for French 1014, Spanish, Portuguese, and these are the 17 languages which have. Hindi 62, Greek 365, Kannada 369, for Malayalam 594 and all. Now the next step is to separate the independent and dependent features. Now we can separate the dependent and independent variables. Here the text data is in the independent variable and the language name is the dependent. So for that we just have to do df, and we have to pass on the value of text should be the column, and for y df will be language. Language. So when I run this, okay, I need to df. Okay. Not df values, not df. Now we'll label encode them. So our output variable, the name of the language is a categorical variable. So for training the model, we should have to convert it into a numerical form. So we are performing label encoding on the output variable. For this process, we are importing label encoder from sklearn. So for that, we have to just import from sklearn.preprocessing import label encoder. Label encoder. L should be equals to label encoder, and y should be named as le.fit underscore transform. You're going to buy while the value. Yes. Now let's run the piece of code. Okay, now it has been run. Now the next step that we're going to perform is basically the most important step, which is the text preprocessing. So this is a data set which is created using the scrapping of the Wikipedia. So it contains many unwanted symbols, numbers, which will affect the quality of our model. So we should perform the text preprocessing techniques. So for text preprocessing, we'll take a data list and we'll equate it with empty list that we're taking. Oh my God, what I'm doing. Okay, yeah. For text in X capital, I'm taking text equals to making use of sub expressions hash dollar comma from the new line, and we have person sign, and we have the power sign, we have the multiplication sign, question mark, colon, value from 0 to 9, 0 till 9. So we'll end. Okay, here it is one more 0, 9, square bracket close. Now we have to replace it with empty space, and we'll have a variable text. Okay, this sentence is wrong. Let me just correct it. Okay, now so it has been corrected. Now again, sub r square bracket, closing bracket, empty space, text. Now we want to convert our text into lowercase, so for that we have text dot lower. Now finally data underscore list dot append, and finally we'll be using text values. I'll run this piece of code, and yeah, we have. So backwards, as we all know that not only the output feature but also the input feature should be of the numerical form. So we are converting text into numerical form by creating a bag of words model using the count vectorizer. So for that, we just have to do from sklearn dot feature underscore extraction text import count search. Now CV equals to, we will instantiate count vectorizer. Now x equal to CV dot fit underscore transform, and we have to pass the data underscore list dot to array dot to array, and finally we'll print the x dot shape. When I run this, okay, so now next step is to print the shape. Now let's just print the shape. For printing shape, we just want to shape. Okay, so this is the output. It contains 10,332 rows and 228,000 columns. Okay, not bad. Now the next task that we want to perform is basically train test splitting. So we pre-processed our input and output variable. The next step is to create the training set, and for the training the model and test set for evaluating the test set. And so for this purpose, we are using a train test split. So again, for that, we just want to do a sklearn dot model underscore selection. We want to import train underscore test underscore split, or to correct it. So okay, so sk EARN. Now we'll be creating train and test set. So So now to create train and test set, x train, x underscore test, y underscore train, y underscore test should be equals to train test split, and the method we have to specify x comma y comma test size, and test size we want only the 20% of the data set, so we'll specify 0.20. Now let's shift to center. Okay, the model has been created. We have trained the model. Now next step is to train our model and also bring out the predictions. So, and we almost there, the model creation part. We are using the naive Bayes algorithm for our model creation. So later we train the model using the training set. So now for model prediction, we have to use from sklearn dot naive Bayes. We need to import multinomial model equals to instantiate multinomial itself in B. Now model dot fit, we have to specify train comma y underscore train. Run along this piece of code. Let's see the model get instantiated or not. Training is being done. Still waiting. I think it's taking some quite time because of the length of the data set is quite huge. So that's why it will take some time to train our model. Okay, so now our model is trained. Now next thing is to just have the prediction. So for having prediction, just need to type model dot predict and pass on our test set. Shift plus enter. Okay, our model has been trained. Now for model evaluation, we can evaluate our model. So for evaluating our model, again, we need to import sklearn.metrics from the metrics library. We need to import accuracy underscore score. Okay, it has given. We need confusion metrics so that we can able see what the recall precision in the F1 score and the classification report. Yeah. Then I'll take AC. I'll just see the accuracy report. I'll pass on the predicted values and the true values. Again, for confusion matrix, I'll pass on the test comma y underscore predict value, and for classification underscore report, we have y underscore test value and y underscore pred value. Okay, now we're good to go. Let me just check the spellings. And spellings are also correct. Now let's shift to enter. Now, in order to print the accuracy, to get the accuracy of the model, just to accuracy is, and we'll just pass the AC. Let's check the accuracy of the model. Okay, so the accuracy of our model comes out to be 98%. So, which is very good, and our model is performing well. So now let's plot the confusion matrix using the Seaborn heat map. So before we do, let's just print the classification report itself. So just print the CR classification report to check the prompt. Okay, so this is the report that is being generated. This is the average weight, macro weight, and weighted average. Everything has been given. Now, in order to visualize the confusion matrix, you have to just make use of fig size equals to 15,10 SNS dot heat map, because we want heat map CM, comma, and note should be value capital true, and for plotting the figure show. Now let's run the code and see the heat map generated. Okay, this looks great. Now when looking into each language, almost all the predictions are correct, and yes, we are almost there. Now let's predict with some more data. So in order to test our model, let's test the model prediction using the text in different languages. Now what I'm going to do is define a function predict text, and what I'm going to do in this function, I'm going to take x cv.transform square bracket text dot to array, which is like, this is basically, if you want to see what this is doing, let me just even write. It's basically converting text to pack of words model vector, because it is doing in the vectorized manner. Don't worry, I'll write comments for it so that you are able to understand it more better. Now this statement is predict plus x. Now what this statement is doing is basically, this step is doing predicting the language. This step is basically important, and it is basically predicting a language. Now LE inverse underscore transform. Now what this step is doing, basically it is finding the language corresponding the predicted value, and finally step will print the language is in, and we'll just print lang with the 0 value. Now this final step is basically printing the language. When I run this piece of code, okay, now function is there. Now let's test our model. So in order to test our model, what we'll do, let's just take each value. So let's take an English word. Now I'm doing this for English, and I'll do predict, recall the function. I'll pass any random English text. So I'll pass, suppose I'll pass, let's take ball provides community based knowledge portal for playing with study. Now when I press Shift plus Enter, now you can see I wrote in English, so it is English. Now let's just take a French word. Don't worry guys, I don't know French, but I'm just copying it from Google. Take for net un or let's take a, have you heard about the analytics Vidya? It's one of the most portal for data science and analytics companies. Now let's take analytics Vidya, FOURNIT un portal de connaissances based sur la. Okay, let me just copy. It's sort of tough task. Let me just copy. Okay. To write only because I cannot copy. For less professional. Now let me just run it here and see, it has accurately predicted that this is French. So you can even have many language also. You can even have some Russian language also. Now let me just copy any random Russian text. Just wait. Let's just have this word. I hit enter and see the language is in Russian. So guys, this was it about a language detection, and that is how you can create your own language detector. And that was an interesting project, right? I hope you might have got an intuition on how such projects are worked out. This would have definitely given you a diagram of basic NLP programs. You need to analyze the data and pre-process it accordingly. A bag of words model become a way of representing your text data. Text extraction and vectorizing are important steps for good prediction in NLP. Naive Bayes always proves to be a better model in such text classification problems, hence more accurate results we get. So this was it, and hope you might have enjoyed the video, and see you in the next video. Thank you.